Hi, my name is Camille Garlick, and I'm a fourth-year industrial engineering student. My roles in this team included assisting in the development of the solutions for the scheduling tool and automated emailing system, as well as ensuring the proper validation and verification of all of our proposed solutions.
My name is Saavedra. I'm a fourth-year industrial engineering student from the Northern Bay Area here in California. During this project, I primarily focused on the RFID-based tracking system, which we designed and proposed to JPL in hopes to implement it in the near future.
My name is Emily Martin, and I am a fifth-year industrial engineering student from Cal Poly San Luis Obispo and the third and final member of the NASA JPL Senior Project Team, or as we like to call ourselves, the Space Cowboys. This past year, I acted as the main point of contact as well as the project manager for our team, kept us on track all year, and I'm super excited to show you everything that we've done over the course of the last 3 quarters. I would also like to point out that all of this work was done remotely as we were all in different locations and JPL wasn't allowing on-site visitors.
That did add to the learning experiences of learning how to collaborate on a virtual space with only Zoom and messaging as our form of coordination.
I will now give a brief overview on how the mechanical inspection facility works for some context. First, parts come in and get placed on the incoming shelf. Then Eric checks them in and looks at their complexity and gauges what type of inspection they will need, either hand inspection, coordinate measuring machine, also known as CMM, rework, or final inspection. The scheduler, Jorge, then logs the part into the queue and schedules what day they need to be inspected by. Inspectors can then go into the system and schedule what jobs they will do for that day. After the part finishes inspection, it gets placed on the outgoing shelf. Within the 6 months prior to starting our senior project, 22% of jobs were completed within 0 to 5 days of receiving said part. The Mechanical Inspection Department at NASA JPL wants to reduce the overall lead time of parts flowing through the lab in order to decrease the turnaround time for big projects. The Space Cowboys are focusing on a reduction of queue time to reduce overall lead time, specifically pertaining to scheduling and readying the part for its inspection. The percentage of jobs completed within the time frame of 0 to 5 days must increase by 20% to significantly improve the efficiency of the mechanical inspection facility. Our team formed in September of 2020, and we spent the first half of our quarter clarifying our roles and establishing the current state of the mechanical inspection facility. We had a lot of ideas as to what we could work on, so we decided to host a Kaizen event to further direct our research and settle on what solutions to move forward with. The Kaizen event was held virtually over the course of 5 days, and we had inspectors fill out a Google form for it to gauge how they picked their jobs, and then during the event we filled out the root cause analysis together. After that, we researched possible solutions before settling on 3 minor and 3 major ones to move forward with. Developing a ranking system for items that come into the queue, developing a protocol to follow when a COGI asks for a job to be expedited, exploring badge reader possibilities to error-proof job choosing, work with the 4T group of JPL to recode the priority queue, develop a schedule quota based off CMM inspector qualifications, and finally implement RFID tags to track assets throughout inspection. We decided on these solutions after our Kaizen event where we found issues with job selection, cognizant engineer interruption, difficulty in tracking part location, and a long scheduling process. However, during winter quarter, we decided to discard or modify those solutions. The first 2 to go were developing the ranking system for items and developing the schedule quota based off of CMM inspector qualifications. As of January 2021, all inspectors are qualified for all CMM inspections, so the schedule quota based off of what they can do became unjustified. Because of this, the ranking system was no longer necessary because all inspectors could do anything, so management would nudge them to just perform the job next in the queue that needed to be done. Finally, we decided to not explore badge reader possibilities due to time constraints. In the end, we had 3 final solutions. The first was to work with the 4T group to create a scheduling view to decrease the number of systems used for Jorge. The second was to work with them to aid in changing the automated email to include a job completion date for the COGIs and to increase the communication and make it more transparent between both parties. Thirdly, we wanted to come up with an implementation plan for RFID tracking within mechanical inspection. Okay, now we'll get started with our design of solutions. First, I'll talk about the scheduling tool. If you take a look at the past date above and the current state below, you will see at the beginning of the year, Jorge would open the priority queue, the old queue, and Trello all at once in order to see when a part would need to be scheduled. He would compile all the information he needed, print it out on a piece of paper, then keep 100 other things in mind while trying to schedule this part. This was a lot of effort, and sometimes his work would go to waste because coggies would just email him asking for expedited work, which meant moving everything else around. As you can see in the now current state process flow map, we were able to consolidate all systems into one, so there's no wasted time going back and forth and everything is all in one spot. This new scheduling window takes out arbitrary information and will include the columns that have the part number, job number, part description, the inspector, the type of inspection, the status, the project, the requester, the proposed schedule date, how many days old it is, and comments. Some features will include multiple select scheduling. It will show how long a part has been unscheduled for, and one will be able to sort and filter each column. Additionally, with the Trello-like feature within the scheduling view, inspectors will have access to all information about the part just by choosing their job within this window.
To verify our solution, we waited 2 weeks after rollout of the new system and then met with the team for a closeout Kaizen event. We received feedback that all aspects of the solution were working as expected and no issues had been found so far. We received verbal feedback from the scheduler Jorge about his experience using the new system, and he let us know that he was very happy with the way the tool had been built out to meet his needs. We were also able to meet the department manager's expectation for time and cost savings, as the consolidation of the 3 systems into one reduced a significant amount of redundant work, as well as eliminated discrepancies and erroneous information caused by having to manually enter data into 3 separate systems. With this information, we were able to validate our solution. We've included a short clip of Jorge providing his feedback on the new scheduling tool.
Being able to see the history of the part, scheduling the part right away, and have the guys working on the same system, moving the parts and complete the inspection jobs, I think it was a fantastic solution. Thank you guys for doing that.
For our second solution, we took a look at the existing automated email that was sent to the coggies after dropping off parts in the inspection department. In the original email, there was only mention of the ID of the part received and a request for a need by date. 2 significant issues were that some coggies had not been able to receive the body of the email, and that there was a lack of time frame informing the coggies of when parts would be completed. This led to many interruptive emails from the coggies requesting updates on their parts that would pull inspectors away from their added value work. Because of this, we suggested the creation of a proposed schedule date that relies on the type of job and historical data to estimate when a job would be completed. This new proposed schedule date would then be automatically populated in both the schedule view for the job scheduler, as well as included in the automated email that would be sent out to the coggies. Additionally, we interviewed coggies to establish a list of features that they would like to see implemented in the solution. You can see some of their responses in the bottom right table. One of their requests that we plan to include is the creation of a 2-way communication system, removing the need for back and forth emails between the coggies and the inspectors. This would improve overall communication between the 2 parties through a designated communication method besides email. Here you can see the current and future state flow charts for processes surrounding the automated email. The future state simplifies the process of communicating the need by date in the case that the proposed date is not satisfactory to the coggie, creating an overall streamlined process. Because of time restrictions, the solution will not be implemented by the completion of our project, so we will be providing a validation and verification plan to our sponsor for their reference once the system is completed and rolled out. The validation process will include circling back with the initial coggies that we interviewed and follow up with them regarding the new system. We will also suggest comparing the number of interruptive emails from before the solution to the number received in the year after the solution. For verification, we really emphasize making sure that all the contents of the email can be seen by the coggies and that the times being generated by the algorithm are accurate and reflective of true lead times.
Our third solution is to confront the issue of confusion regarding part location in or around the facility by creating an RFID-based asset real-time locating system, or RTLS for short. An interesting caveat with this solution is that JPL wants to implement a consistent RFID system across the entire laboratory, a task that is far outside the scope of this project. As such, the solution is presented in the form of an implementation plan for JPL to use as a prototype for only the mechanical inspection department before expanding to the laboratory as a whole. There are 2 primary goals in implementing this type of system. The first, as mentioned earlier, is to confront the issue of misplaced assets in the facility. Increasing process visibility in this way will eliminate misplacement error and the time required to rectify the situation, subsequently decreasing overall lead time. The other goal in implementing a tracking system is for the long-term benefit of justifying further continuous improvement. Having data that shows the locations of bottlenecks in the system can be used to validate improvement initiatives that the department comes up with for years to come. Thorough research and consultation was conducted to find the best technology that fits the considerations of the mechanical inspection facility, such as facility size and radio frequency interference due to metallic surfaces, among other considerations. Ultimately, the team settled on an RFID hardware manufacturer called Coupa, whose use of low-frequency Bluetooth technology and their intelligent locating system perfectly fits the requirements of the mechanical inspection department. Conversations over email with Tom Ruth, the VP of Coupa in the United States, gave some very valuable insight into how the system could be effectively implemented in the facility. Due to the relatively small size of the facility, only about 2,250 square feet in total, he estimated that only 3 readers would be needed to properly pinpoint the location. Ruth suggested that JPL purchase the locating system development kit, pictured in the top right. The development kit comes at a cost of $5,450 for 6 readers, 5 tags, and the controller, which generates coordinate locations. Additional tags are $18 each, and the software would be integrated by one of Coupa's partners or the 4T technology group at JPL.
Now we'll talk about our impact analysis. New process implementation can always cause unrest and annoyance among employees. However, we know that the changes will result in a more transparent, communicative relationship between mechanical inspection and COGIs, thus increasing morale. Additionally, we made sure to involve the employees through the Kaizen event, through interviews, to make sure that the transition went smoothly from one interface to another and they felt like they were included in the design process. As for our environmental impact, both the scheduling tool and RFID implementation will eliminate printing for the required documentation and reduce waste. By far, our biggest impact is our financial impact. With the automated email, we will save about $382,000 and the scheduling tool anywhere from $50,000 to $67,000 per year. These costs combined save about $450,000 a year, with just over 2 years us saving $1 million for mechanical inspection. At the very beginning of our project in September, our sponsor, Tanya, defined key success metrics as reduction in cycle time, fewer steps in the process, fewer systems to access, reduction of manual data entry, and ease of use. Our thorough research and verification and validation plans have assured us that even though a solution may not be implemented yet, all 3 of our solutions meet at least one, if not all, of these key success metrics. Although the scheduling tool has only been implemented for about a month, recent data has shown that 44% of jobs coming into the queue have been completed within 0 to 5 days, compared to the original 22%.
This was a great experience working with the Space Cowboys. Even with working remotely, it's been successful. The process of involving the whole inspection team, as well as our internal 4T group and our customers, resulted in some improvements we are already benefiting from. Our new schedule view is working wonderfully and saving us time. We look forward to continue implementing the COGI email, as well as working within JPL for RFID options based on the proposals given. Overall, a pleasure working with Emily, Camille, and Jack. Thank you all.
Jack, Camille, and I are all extremely proud and excited to have successfully contributed to a more efficient mechanical inspection, a more efficient jet propulsion laboratory, and a more efficient NASA.